we now turn our attention to what we call cartilage. Remember, we said that cartilage is one of the unique or special or specialized connective tissues. So when we talk about cartilage, we shall talk about bones, and then we shall now move to the other tissues. So in this session, we want to know what cartilage is. Why do we actually say that cartilage is connective tissue? Where do we find it? We have different types of cartilage. Okay, that's what we are going to look at here. So cartilage is a connective tissue. Why? Because like with all other connective tissues, we are talking about the fact that they actually provide support. Okay, so cartilage provides support. So they also have components that are similar to the other connective tissues. You have matrix in there. You also have cells in there. Okay, so what cells do we find there, and what is the name of the matrix that we find in cartilage? Okay, so the cells are in the matrix that we call chondrine. Okay, the matrix that we find in cartilage is chondrine. Okay, the cells in cartilage, we have the fibroblasts. Okay, the fibroblasts. These ones are the ones that produce the fibers, the collagen the fine collagen fibers that we find in cartilage, but also the matrix. But then they can be encased. When they become encased, the meaning of that is that when they are covered in the lacunae, then they become the chondrocytes. They become chondrocytes. So remember, we're saying that it is the chondroblasts that are doing the work of producing the matrix, but also producing the fine collagen fibers. Okay, so that's what we're not talking about cartilage. We're talking about the things that we talked about for connective tissues. Matrix, talking about the cells, talking about the fibers. Okay, and then what is within the matrix? Okay, what is within the matrix? And of course, one of the other components that I don't want you to forget is about the vasculature of connective tissues. Is the other component. Okay, so cartilage. Cartilage is surrounded by what we call a dense layer. The outer layer of the cartilage is what you call the perichondrium. Okay, and then in there you have cells and the fibrils. Okay, so that outer covering produces the new chondroblasts. Okay, so remember, the chondroblasts are actually the primary cells that we find in the cartilage. Okay, so the cartilage is actually very important because it contributes to growth. Okay, so remember that in what we shall look at later is how cartilage can actually be turned into bones. Okay, so that means that cartilage actually plays an important role in growth, okay, and maintaining. So these cells also maintain the cartilage matrix. Remember, the chondroblasts produce the matrix, but also produce the fibers, okay, the thin collagen fibers. Okay, so for it is not as compact. Cartilage is not as compact as, for example, the bones, and it's elastic to some extent. And then the collagen fibers in the matrix are the ones that provide that kind of resistance to tension. Okay, so where do we find this cartilage? The nose, the pinna, and then also in the vertebral column, from one vertebrae to the other, there is what we call intercalated. We have the intervertebral discs. Those intervertebral discs are actually cartilages. Okay, and then the railings. Okay, so we have three types of cartilage: hyaline cartilage, white elastic cartilage, and then white fibrous cartilage. Which one could you expect to be more strong? Tensile strength. I guess you're basically saying the white fibrous cartilage. Elastic fibers are stretchable. You also remember that discussion, right? So let us look at what you call the hyaline cartilage. So the hyaline cartilage is the simplest of the types of cartilage. It is elastic and compressible. It contains a semi-transparent matrix and the chondrocytes that with the fine collagen fibers, or the fibrins, you can call. There are no blood vessels in there. The materials, the cells in there get what they want through diffusion. Okay, so this cartilage is what we find between bones and here around joints. Okay, and then the nose, the trachea, the bronchi, and then the embryonic skeleton. Before the baby is born, some months before the baby is born, the baby has or consists of cartilage. The bones have not yet been formed, because remember we said that some of the bones are actually made from cartilage. It is cartilage that transforms into bones. So we are saying that in embryonic stage, the skeleton there is cartilaginous, but it will later, some of the bones will later turn, some of the cartilage will later turn into bones. Okay, like we said earlier, that elastic cartilage or yellow elastic cartilage is elastic, stretchable. It's not very strong. So it is because of the yellow elastic fibers that give this cartilage that elasticity and flexibility. So your pinna, the outer ear, is actually made up of this elastic cartilage. Okay, so when you pull your ear, it will return back to its shape. So that means that it has that this cartilage has the ability to return quickly to its original shape after distortion. The epiglottis and the pharynx, these are the other parts that actually have this yellow elastic cartilage. So the ones that we said is very tough is the white fibrous cartilage, and in here we are talking about collagen fibers that give it that great tensile strength and a little bit of some flexibility. Okay, so you are able to bend and do some slight movements of your back because of the flexible cartilage that you have. Okay, and that is basically white fibrous cartilage. Okay, so we find it in the back, that is the vertebral column. The intervertebral discs are actually white fibrous cartilages. Okay, ligamentous capsules around joints. You also find this white fibrous cartilage.